Good day, everyone. My name is Carlea Maria G. Aguinaldo from BSCS-2B, and today I am going to discuss about understanding the interaction between set theory and set operators in SQL Server. So first, what is a set? So a set is exactly defined as collection of objects. So objects in this collection is called or are called members or elements. So the significant point of a set is that members or elements should be defined exactly and clearly. Definitions whose members or elements that are not defined exactly or explicitly, it does not identify as set. So sets are frequently named with capital letters. So members or elements, or let's just say elements of a set can be written between the curly brackets. This is a curly brackets, and can be separated or should be separated by a comma. So this representation is called tabular or roster form. For example, okay, I'll be using this one. So I'll be showing you the example of tabular or roster form. So for example, the X will represent the month of winter or the winter season. So X set and the month of winter season, which are December, January, and February. So as you can see, the set is named or written with a capital letter, and the elements of this set is written between the curly brackets and separated by a comma. And also, set can be represented by a Venn diagram. Venn diagram. So like this one. The name of the set, Venn diagram, December, winter season pa rin, or season of winter season, December, January, and February. So this one is a Venn diagram. So now let's proceed to the universal and empty set concept in the set theory. So a set should provide two essential properties. So number one, the members or a set member can only exist once. And number two, the order of the members is not important. Okay? So universal set. So what is a universal set? So universal set is a particular type of set, and the theory assumes that universal set covers all the set members in the universe, and it is represented by the letter U. Right, or this symbol. Okay? And on the other hand, this the empty set. So what is an empty set? If the set does not have any members, it is called empty set or a null set. Okay? Or null set. and it is denoted by this sign or this sign, brackets that does not have any members at all. Okay? So, union of sets. According to the set theory, we can union two sets so that we can obtain a new set that contains all the members of the union sets. For example, the A and B sets. And the members of these sets will be fruits. Okay, so fruits. Apple, orange, strawberry, lemon, and avocado. This is for the set A. So for the set B, lemon, apple, grapefruit, and apricot. So, the set letter A and the set letter B will look like this in Venn diagram, okay? Wait. Wait. No. So, it will look like this. So, I'm going to erase this one. So, for the set A and set B, we must remember apple, orange, strawberry, lemon, and avocado. These are the members of set A. And for the set B, lemon, apple, grapefruit, and apricot. So these are the members of set B. But at this point, we must emphasize one issue here. As we said about the properties of our set, the members of the set should be shown once in the union set. So, their common sets can be shown only once. So, what are the common sets? It is the apple and the lemon. So, these two members should be written in the middle. Because, as I've said, common sets should be shown once. So, lemon, apple. Erase, 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 erase. Sets A and B will look like this, and it is denoted by A union B. Okay? In the SQL server, the union operator concatenates the result set of the two tables. It eliminates the duplicated rows from the result set. In fact, the union set, or should I say the union operator in the SQL server, acts as the union operation or the union operator in the set theory. So suppose that the set A and B is represented by a table in SQL Server. So at this point, we are going to create tables in the SQL Server. So when you create a table in the SQL Server of these two sets, so this is the syntax. So as you can see in the screen, this is the syntax. Okay. So when you union it in the SQL, or when you use the union operator in the SQL Server, this will be the query. Okay, so this will be the query, and this is the result. When we union the two sets, the result will be similar to A union B result. Okay, so this will be the result. Next, when we change the order in the query, like this query, when we change the order of this query, the result will remain like this in the SQL Server. So you guys must try it when you have time. Okay? So now let's proceed to the intersection of sets. So intersection of sets. So the intersection of two sets generates a set that contains the common members of the intersected sets. So now we will observe the intersection of A and B sets. So the A intersection B is denoted by A intersects B. Okay? So in this area, the result will be lemon and apple, because these two members is the common members or common elements of the set letter A and the set letter B. Okay? And A intersects B is equal to B intersects A. So the result of these two is the same. Okay? So this illustrates the intersection of A and B sets in Venn diagram. Okay? So there are two common sets. Remember, there are two common sets. There are two common members rather, is lemon and apple. In SQL Server, the intersect operator implements the intersection logic of the set theory. So now, we will find the intersection of the table A and table B with the help of this query. So this query. Okay? So this query, the result will be this. Okay? As you can see in your screen, that is the result set for our first query. But when we change the order from this query to this query, the result set will still remain like this. In short, it will not change. So now, let's proceed to the difference of sets. Alright. Difference of sets. Members that are in a set and does not exist on another set is called set difference. So, in A difference B. So, A difference B is denoted by this. Okay? This one. A difference B. Okay, so A difference B is not equal to B difference A. Alright? Because A difference B is equals to A minus B. A minus B. So, A minus B is equals to grapefruit, apricot only. But when B minus A, the result will be orange, strawberry, and avocado. So this illustrates the A difference B in Venn diagram. Okay? In SQL Server, with the help of except operator, we can obtain the difference between the two tables. So this will be the query. Okay? A difference B. This is the first query, and this query can result to this table. Okay? At this point, when we change the order of the two tables, we will have a different result. So this is the new query, and this will be the new result. So as you can see in SQL Server and in the set of or in the set query, the result is different. As I've said, A minus B or A difference B is not equals to B difference A. Okay? So, in conclusion of this topic, while the set is an abstract concept, we have seen that it became a concrete reality through relational database theory. Okay? For the last time, I will leave you a quote by Shakundala Devi that without mathematics, there is nothing we can do. Everything around you is numbers. Everything around you is mathematics. Thank you.